Let's look at the three top-level security elements in the deployment descriptor one at a time. First, the LoginConfig element. The most important part of the LoginConfig element is the authentication method that is specified. In this case, it is form, but there are several others. The basic authentication mechanism transmits the username and password in an encoded but not encrypted manner. This hardly provides any security at all. When basic authentication is used, an operating system dialog box pops up when a client wants to access a protected area. The form authentication mechanism allows the web application designer to create a custom form for the username and password, but it requires that the form have certain well-defined parameters. The form mechanism has no security. Therefore, it is almost always used in conjunction with the integral or confidential transport guarantee in the user data constraint element, which secures data using the SSL or TLS protocol. The digest mechanism is similar to the basic mechanism, but it actually encrypts the username and password. The encryption used, however, is still weaker than that used in SSL. The client cert mechanism uses strong public key encryption that requires not only the server to have a certificate, but also the client. Therefore, this mechanism is typically reserved for use between two businesses. Here's a visual representation of the basic authentication mechanism. The client requests a protected resource from the server. The server determines that access to the resource is protected, so it asks for a username and password. On the client side, this request appears in a dialog box rather than a web page. The client fills out username and password and submits the dialog box. This results in a second request to the server, which asks for the same resource, but this time includes an HTTP security header along with an encoded username and password. The sequence is stateless, so the second request is independent from the first. Finally, the server confirms that the username and password match, so it returns the requested resource. In the deployment descriptor, this is all you need for basic authentication. In fact, this is all you need for most authentication mechanisms with the exception of form authentication. The realm name, which we will talk about shortly, will default to a vendor-specified value if you leave it out. So a Glassfish server will have its own default realm, and a Tomcat server will have its own default realm. Form authentication is probably the most used and the most interesting. So let's take a look at how that works. In form-based authentication, the client requests a requested resource. The server determines that the resource is protected, so it redirects the client to a login page with a form in it. Now, that form must fulfill very specific requirements. It should use a post method, and it must request the resource named JSecurityCheck. It also must send the username and password using the parameters JUsername and JPassword. The client submits the form, and the JSecurityCheck resource looks up the JUsername and JPassword information in the appropriate realm. And it decides whether the user can be permitted to see the originally requested resource. If the user does have permission, the original resource is sent. If the user does not have permission, then the client is directed to a custom error page. and that is form-based authentication. But there's one thing we didn't really mention here. When the client makes the second request, it requests the JSecurityCheck resource. Since requests are stateless, how does the server know what resource was originally requested? Well, the answer is it's only going to know if you have some sort of session tracking turned on. Recall that we said earlier that since this mechanism has no security, that is, the username and password are sent to the server in plain text, this technique is almost always used in conjunction with SSL. Well, it turns out that SSL has its own session tracking. So using this with SSL takes care of the session tracking problem. But just be aware you should use some sort of session tracking with this technique. When you indicate form authentication in the deployment descriptor, you are required to provide a form login config element. This element must contain locations of both a login page and an error page, should the login fail. As mentioned in the last slide, the login page must contain the HTML shown here, with these exact names for the action, JSecurityCheck, and the parameters JUsername and JPassword. The login config element should also contain a realm name element, though if it is missing, a default value will be used. The realm name indicates where the server should look for authentication and authorization information, such as usernames, passwords, and access groups. The possible places the information can be stored include a text file, an XML file, a relational database, or an LDAP server. The realm name is vendor specific. In other words, it depends on the server. For the Glassfish server, the name file indicates that authentication and authorization information will be stored in a file with a name key file. The key file is located in a configuration directory under the main Glassfish application directory on your system. This is an example of a key file that stores 3 users, Alice, Bobby, and Carol. It also stores hashes of their passwords using the SHA-256 hash function and the user groups that they belong to. Storing the hash values of passwords is more secure than storing passwords themselves. If an attacker obtains the hash value, they still do not have access to the original password. And only hash values are needed to verify that 2 passwords match. The groups here are server-defined groups. Role names in your application may or may not differ from these group names. Keep in mind that this key file applies to the Glassfish server as a whole and not to individual applications. However, there is a way to ensure that key files are just accessible to one subdomain of the server.